A motherboard is like the main circuit board of your computer. It is the central hub that connects all the different parts of your computer together, allowing them to communicate and work in harmony. It is a big piece inside your computer case, often taking up a significant portion of the space. The motherboard is designed to hold and connect various components. The motherboard holds many important parts, such as the CPU, RAM, and GPU. These components are essential for the computer's performance and functionality. These parts all work together seamlessly thanks to the motherboard. It ensures that data flows smoothly between the CPU, memory, and other peripherals. The motherboard connects everything in your computer, from the power supply to the storage devices. It has various slots and ports for different components and peripherals. Think of it like the foundation of a house. Just as a house needs a strong foundation to stand, a computer needs a motherboard to function properly. It provides a place for all the other parts to connect and work together. The motherboard's design ensures that each component fits perfectly and operates efficiently. Without a motherboard, your computer wouldn't work. It is the backbone that supports and integrates all the essential parts, making it a crucial component in any computer system. The concept of the motherboard has evolved significantly over the years. In the early days of computing, motherboards were much simpler and less integrated. In the 1980s, motherboards began to include more integrated circuits and components, reducing the need for multiple separate circuit boards. Today, motherboards are highly advanced, featuring integrated graphics, sound, and network capabilities. They support a wide range of peripherals and offer extensive customization options. As technology continues to advance, motherboards will keep evolving, offering even more features and better performance. They remain the heart of any computer system, ensuring all components work together seamlessly. The motherboard's job is to connect and control all the parts of your computer, acting as the central hub. It lets them talk to each other seamlessly. For example, the motherboard lets the CPU talk to the RAM, ensuring quick data access. The motherboard also connects to your monitor, keyboard, and mouse, facilitating user interaction. It manages the flow of data between all these components efficiently. This ensures that everything works smoothly and efficiently, providing a stable computing experience. There are various types of motherboards, each designed for specific uses. For instance, ATX motherboards are common in gaming rigs due to their expandability, while micro ATX boards are often found in compact desktops. Server motherboards with multiple CPU sockets are used in data centers, and workstation motherboards support high-end components for professional tasks. Each type of motherboard has unique features such as PCIe slots for graphics cards, RAM slots for memory, and various power connectors. Understanding these differences helps in choosing the right motherboard for your specific needs, ensuring optimal performance and compatibility. The CPU socket is where the brain of your computer goes. This is the central processing unit, or CPU, which handles all the instructions from your software and hardware. It's crucial for the overall performance of your system. The CPU socket ensures a secure connection and proper alignment of the CPU pins with the motherboard. It's like the socket in your wall, but for the CPU. Just as you plug in a device to get power, the CPU socket connects the CPU to the motherboard, allowing it to communicate with other components. The socket type must match the CPU type to ensure compatibility. RAM slots are where you put the RAM sticks. These slots hold the memory modules that your computer uses to store data temporarily while it's running. The number of slots and their configuration can affect the amount of memory your system can handle. RAM is like your computer's short-term memory. It allows your system to access data quickly, which is essential for multitasking and running applications smoothly. Different types of RAM, such as DDR3 or DDR4, have varying speeds and capacities, impacting overall system performance. The motherboard has slots for expansion cards. These slots can be used to add additional capabilities to your computer, such as improved graphics, sound, or network connectivity. Common types of expansion slots include PCI, PCIe, and AGP. These cards add extra features to your computer. For example, a graphics card can enhance your gaming experience, while a sound card can improve audio quality. Network cards can provide faster internet connections, and storage controllers can add more hard drives or SSDs. It also has connectors for your hard drive and other storage devices. These connectors allow you to add storage for your files, applications, and operating system, ensuring your computer has enough space to function efficiently. Common connectors include SATA for hard drives and SSDs and M2 for high-speed NVMe SSDs. Power connectors are another crucial part of the motherboard. They supply power to the CPU, RAM, and other components. The main power connector, usually a 24-pin ATX connector, and additional 4 or 8-pin connectors for the CPU, ensure stable power delivery. The chipset is the motherboard's traffic controller. It manages data flow between the CPU, RAM, and other peripherals. Modern motherboards often have two main chipsets: North Bridge, which handles high-speed communication, and the South Bridge, which manages lower-speed peripherals. Lastly, the I/O ports on the motherboard provide connectivity for external devices. These include USB ports, audio jacks, Ethernet ports, and video outputs. They allow you to connect peripherals like keyboards, mice, monitors, and external storage devices, making your computer versatile and user-friendly. The motherboard is essential for a computer to function. It serves as the main circuit hub that allows all the components of your computer to communicate with each other. Without it, the other parts wouldn't be able to communicate or work together. Think of it as the backbone of your computer, holding everything together and ensuring seamless interaction. It's like the conductor of an orchestra, making sure everything works in harmony. Every signal, every piece of data passes through the motherboard, orchestrating the performance of your computer. Choosing the right motherboard is crucial when building or upgrading your computer. It affects the compatibility and performance of your system. It determines what components you can use and how powerful your computer can be. From the type of CPU and RAM to the number of USB ports and expansion slots, the motherboard dictates the potential of your machine. When choosing a motherboard, consider the type of CPU socket it supports. This will determine which processors you can use. Also, look at the RAM slots and the maximum amount of memory it can handle. Pay attention to the number and type of expansion slots available. If you plan to add multiple graphics cards or other peripherals, ensure the motherboard can accommodate them. For gaming or high-performance tasks, choose a motherboard with robust power delivery and cooling solutions. This ensures stability and efficiency under heavy loads. Lastly, consider the connectivity options. More USB ports, faster Ethernet, and Wi-Fi capabilities can enhance your overall experience. The right motherboard can make all the difference in your computer's performance and longevity. As technology continues to evolve at a rapid pace, the future of motherboards holds exciting possibilities. Upcoming advancements promise to push the boundaries of what our computers can achieve. Let's take a look at some of the trends and technologies that are set to revolutionize the motherboard landscape. One of the most anticipated advancements is the integration of more advanced AI capabilities directly onto the motherboard. This will enable smarter, more efficient processing right at the hardware level, reducing latency and increasing performance for tasks like real-time data analysis and complex computations. Another trend is the move towards more modular designs. Future motherboards may offer greater flexibility, allowing users to easily swap out components like RAM, storage, and even CPU sockets without needing to replace the entire board. This modularity could extend the lifespan of a motherboard and provide more customization options for users. We're also seeing a shift towards increased connectivity. With the rise of 5G and Wi-Fi 6E, future motherboards will likely come equipped with these advanced networking capabilities, ensuring faster and more reliable internet connections. Enhanced support for Thunderbolt and USB 4 will also provide quicker data transfer rates and more versatile peripheral connectivity. In terms of form factor, expect to see more compact and efficient designs. As components become smaller and more powerful, motherboards will follow suit, enabling sleeker and more portable computer builds without sacrificing performance. Additionally, advancements in power delivery and thermal management will play a crucial role. Future motherboards will incorporate more sophisticated power regulation and cooling solutions, ensuring that even the most demanding components can operate efficiently and reliably. Lastly, sustainability is becoming a key focus. Manufacturers are exploring eco-friendly materials and energy-efficient designs to reduce the environmental impact of motherboard production and operation. The future of motherboards is bright and full of potential. With these innovations on the horizon, our computers will become more powerful, flexible, and sustainable than ever before. Installing a motherboard might seem daunting, but with the right steps, it's a straightforward process. Let's walk through it together. Step 1. Gather your tools and components. Before you start, make sure you have all the necessary tools and components. You'll need a Phillips head screwdriver, your motherboard, the computer case, and any components like the CPU, RAM, and storage drives. Step 2. Prepare the case. Open your computer case and lay it flat on a stable surface. Remove any panels to give yourself plenty of room to work. Check the case's manual for any specific instructions or standoffs that need to be installed. Step 3. Install the I/O shield. Locate the I/O shield that came with your motherboard, align it with the cutout on the back of your case and snap it into place. This shield will protect the motherboard's ports and help align it correctly. Step 4. Align and secure the motherboard carefully. Place your motherboard into the case, aligning it with the standoffs and the I/O shield. Once aligned, use the screws provided to secure the motherboard to the case. Make sure it's firmly in place, but avoid over-tightening the screws. Step 5. Connect power cables. Next, connect the power cables from the power supply to the motherboard. This includes the 24-pin ATX power connector and the 8-pin CPU power connector. Ensure they're securely plugged in. Step 6. Install additional components. Now install any additional components like the CPU, RAM, and storage drives. Follow the manufacturer's instructions for each component, ensuring they're properly seated and connected. Step 7. Connect peripheral cables. Connect any peripheral cables, such as those for the front panel, USB ports, and audio connectors. Refer to your motherboard's manual for the correct pin configurations. Step 8. Double-check everything before closing the case. Double-check all connections to ensure everything is properly installed and secured. Look for any loose cables or components. Step 9. Close the case and power up. Once you're confident everything is in place, close the case and secure any panels you removed. Connect your computer to a power source, monitor, keyboard, and mouse. Power it on and check that everything is functioning correctly. Congratulations, you have successfully installed your motherboard. With these steps, you're well on your way to building a powerful and efficient computer.